Hello. And welcome to another fantastic, outstanding Phillips podcast, or P squared. And let's just hope this podcast is better than the Chicago Bulls' performance in Game 4 against the Atlanta Hawks. -10. We're not going to talk about it right now. Today's podcast is on lesson 6.3, Approximating Square Roots. By the end of this podcast, you should be able to identify rational and irrational numbers. You should also be able to approximate or estimate square roots. Some vocabulary words we're going to look at today before we give the dice the old spinaroo. Don't think that's a word, but it sounds good. Over here, I'm going to write rational. And I'll abbreviate numbers. And on this side, I'll write irrational numbers. All right, natural numbers, we're going to put over on this side under rational numbers. You can think of natural as whole numbers. Those are like 1, 2, 3, ... Whole numbers, natural numbers, they are always classified as rational. Give her old spinaroo. Here you got to spin again. We already did that one. All right, rational numbers we have over here, and we're going to talk more about that in our podcast in a minute. Rational numbers we have over here. We'll talk more about irrational numbers in a minute. All right. Those of you who jinxed my cube out there, -10 for you. Because I'm telling you, there's more on here than this. See? Integer. By definition, integers are always going to be rational numbers. Integers are positive and negative numbers. Integers are always going to be a rational number. I think there's 2 more out there. I'm telling you, there's 2 more out there. See? Terminating decimal. By definition, a terminating decimal is a decimal that ends. Terminating decimals are always classified as rational numbers. And there should be repeating decimals in here somewhere. See, I told you, +10 bears. Repeating decimals are always going to be classified as rational numbers. So that leaves us to talk about irrational numbers, which we're headed right to. They give you this picture in your math book. You can find this picture in your math book on page 246. Natural numbers, integers, are all in the category of rational numbers. Everything else is classified as an irrational number. And together, rational and irrational numbers make up what we call real numbers. Alrighty. I'm going to fill in numbers on this chart, and then I'll go back up and show you the definition. I'm going to say the square root of 9. The square root of 9, by definition, is 3. And we should know that the square root of 9 is what we call in math a perfect square. So anytime you have a perfect square, that's going to go in the rational column. Right here. Rational numbers are always perfect squares. So if you said, Mr. Phillips, what about the square root of 49? Well, 49, by definition, is a perfect square. Perfect squares are always rational numbers. What if you said, Mr. Phillips, how about 8? By definition, 8 is what I call a whole number, or what the book calls a natural number. Whole numbers or natural numbers are always rational numbers. Right here, rational numbers are always whole numbers.
All right.
Let's say I add to the column -8. -8 is what we call an integer. By definition, rational numbers are always integers. If you come back up and look at the picture they have on page 246, integers, negative, positive numbers are always rational. What if I gave you the fraction 3/5? Take a calculator and do 3 divided by 5, and you get 0.6. 0.6, by definition, is what we call a terminating decimal. Terminating decimals are rational numbers. Terminating decimals are rational numbers. If I gave you the fraction 1/3, take your calculator. Ooh, you don't have a calculator? -10 for your group, plus 10 bears. If you divide that on your calculator, you get 0.33333. Excellent job. You made up for it by saying 0.3 repeating with bar notation. Repeating decimals are always rational numbers. So you have terminating decimals, and we have repeating decimals. Repeating decimals are always rational numbers. If I gave you a mixed number, let's say 2 and 4/7. 2 and 4/7, it's a mixed number. Mixed numbers are always rational numbers. All right, well, gee whiz, Mr. Phillips, that helps me identify rational numbers, but what are irrational numbers? Well, here's an example of an irrational number. Let's say I do the square root of 8. Take a calculator. If you hit 8 square root, you get 2.8284. 271. -10 bears. I'm looking at this decimal. It's not a terminating decimal because it doesn't end. And it's not a repeating decimal because there's no pattern here. So by definition, at least Mr. Phillips' definition, any irrational number is a decimal that's not terminating and it's not repeating. Irrational numbers are decimals that do not terminate and they do not repeat. Pi in math is an irrational number because if you worked out pi, the first digits are 3.1428571. This does not terminate and it does not repeat. So by definition, if it doesn't terminate and doesn't repeat, it is an irrational number. This chart is in your book, and it's located on page 246. I want to know whether these numbers are rational or irrational, and you have to explain why. So I'm going to take my calculator, and I'm going to hit 12 square root, and I get, when I do that, 3.4641016. This decimal is not terminating, and it's not repeating. Since it's not terminating and not repeating, we say it is irrational. Or, excellent job, plus 10 for your group, because you could have told me that that 12 square roots is not a perfect square. All right, let's take a look at our next example. Negative 0.364, repeating. Well, this gives me a huge clue right here, because this is bar notation and it tells me that the 4 keeps repeating. I remember by definition rational numbers are decimals that terminate or repeat. Rational numbers are decimals that terminate or repeat. So since this is a repeating decimal, I'm going to say it is rational. And I'll just abbreviate over here, repeating decimal. Negative 1 3/7. Mixed number, I'm going to say it is rational. And 0.85. That's a decimal. It's not repeating, but it is terminating. It comes to an end. So by definition, rational numbers are terminating or repeating decimals. Rational numbers are terminating or repeating decimals. In this case, this is a terminating decimal. All right, it's going to practice approximating square roots. They asked me to estimate the square root of 52 to the nearest integer. Well, if I look on a number line, the square root of 52, or the number 52, the number 52 is close to 49. If you said 52 is close to 64, I would say plus 10 bears, because 52 is closer to 49. Because 52 is closer to 49, the square root of 52 is closer to 7. So we're going to estimate, it's not an exact answer, it's just an estimate, that the square root of 52 is 7. If you don't want to use a number line, you can take your handy-dandy calculator, plus 10 bears if you didn't grab one already, and you could type in your calculator 52 square root, and that would give you 7.2111025, plus 10 for your group if you told me this is an irrational number. And you could ask yourself, if I'm thinking of money, is $7.21 closer to 7, or is $7.21 closer to $8? $7.21 is definitely closer to $7. That's why we estimate it to be 7, not 8. Comparing real numbers, which is greater, the square root of 5 or 2 3/4? Take your handy-dandy calculator, type in 5 square roots, and you get 2.2360679 plus 10. If you told me, Mr. Phillips, this is an irrational number, it's not terminating, it's not repeating, there's no pattern to it. Excellent job, plus 10 for your group. BTW, I hope you're keeping track of your score, because I totally forgot. I'm going to think of money. I'm going to say 2 3/4 is like $2.75. I'm going to ask myself, which is greater, $2.23 or $2.75? $2.75 is greater. So 2 3/4 is greater than the square root of 5. Approximating an expression. The radius of a circle with an area A is approximately the square root of A over 3. The area of a circular mouse pad is 51 square inches. Estimate its radius. Important information. Area is 51 square inches. So here's my formula. The square root of A over 3. Where'd I get it from? Right here. I'm not smart enough to make this up, guys. Just go back and get it from the problem. Now, I'm going to, excellent job. If you said plug and chug or substitute, plus 10 for your group. If the area A equals 51, I'm going to plug and chug 51 in for A. You should be able to look at this and say this means 51 divided by 3. I'm going to rewrite the problem. 51 divided by 3. Take your handy-dandy calculator, plus 10 bears if you didn't get one yet. 51 divided by 3 gives me 17. Easy come, easy go. All right, I lost my 10, but I'll get it back. My answer is not 17 because now I need to go back and do the square root of 17. When I do the square root of 17, I get 4.1231056 plus 10 bears because I beat you. This is, by definition, an irrational number. It doesn't terminate. It doesn't repeat. There's no pattern. I'm going to estimate my answer to 4. Or plus 10 bears because you could have said the square root of 17 is really close to the square root of 16. The square root of 16 is 4. In either case, it's not an exact answer. It's just an estimate. And, nice try. Thanks for reminding me. My unit is inches. 4 inches. Shouldn't have said anything. Thanks for your help. All right, real life application. The distance in nautical miles, you can see what the periscope is, 1.17 square root of h, where h is the height of the periscope above the water. Can a periscope that is 6 feet above the water see twice as far as a periscope that is 3 feet above the water? Explain. I'm thinking I'm going to write my formula. Minus 10 bears. And I'm thinking 6 feet is the height. I'm going to substitute plug and chug. See, I knew I'd get my 10 back. 6 and 4, h. I'm going to do the square root of 6, which gives me 2.4494897 plus 10 bears. This is an irrational number. They're touching. That means multiply. So I'm going to multiply 1.17 by that number. That irrational number. Nice job, Mr. Phillips. That gives me 2.8659029. If you said this is an irrational number, good for you. I'm going to put a box around it and come back to it because I think I'm going to need that number later on. I'm going to write my formula again, 1.17 square root of h. I did the problem for 6 feet. Now I'm going to plug and chug for 3 feet. Take the handy dandy calculator and do 3 square root, which gives you 1.73200508. I beat you. Irrational number. Nice job, Bears. Times 1.17. That gives you an answer of 2.0264994. Irrational number, plus 10 bears. Too bad the real bears can't do this much. All right, so here's my two answers. Can a periscope that is 6 feet above the water see twice as far? Twice as far. Well, the question is 2.02 twice as far? So I'm going to estimate this number, round it to 2.03. I want to know if it's twice as far. I'm going to times it by 2. And I get 4.06. Well, I'm going to come back up here and look at this number. For it to see twice as far, I have to see at least to 4.06. This isn't 4.06. So the answer is no. And it cannot see twice as far. Tell whether the number is rational or irrational. Explain. Take a calculator, do 12 square root, and you get 3.464116. Well, you could say, Mr. Phillips, 12 is not a perfect square, or this is not a terminating or repeating decimal. So by definition, this is an irrational number. Negative 3/7. By definition, negative 3/7 is a ratio of two integers. Since it is a ratio of two integers, it is a rational number. 0.489 repeating. Since this is a repeating decimal, repeating decimals are rational numbers. Estimate to the nearest integer. Well, 8 is really close to 9. So I'm going to say the square root of 8 is really close to the square root of 9. 9 is a perfect square, so 9 is a rational number. The square root of 9 is a rational number. And I'm going to estimate that to be 3. The square root of 60. I'm going to ask myself, what are my perfect squares? Well, I know that 64 is a perfect square, and I know that 49 is a perfect square. I do believe that 60 is closer to 64 than 49, but the Cubs would probably say that 60 is closer to 49. So I'm going to estimate the square root of 60 to be the square root of 64. The square root of 64 would be 8. Again, this is just an estimate. It's not an exact answer. All right, in this problem, this means 172 divided by 25. I'm going to ignore my negative sign for now. When I take my calculator, you take your calculator, plus 10 if you don't have a calculator for the bears, and divide it by 25. That gives you 6.88. I'm going to round or estimate 6.88 up to 7. Well, I'm going to ask myself, I need to find the square root All right, sorry about that. So I need to do the square root of 7, but I'm estimating. Well, I know that 9 is a perfect square, so I'm going to estimate this to the square root of 9 because 9 is a perfect square, and the square root of 9 is 3. Now I'm going to come way back up here. Remember that your dog follows you woof, woof, wherever you go. So this is just an estimate. Square root negative of 172 over 25 is a -3. Not an exact answer, just an estimate. All right, guys, I'm going to skip problems 7 through 9 and go right to 10. The velocity in meters per second of a ball that is dropped from a window at a height of 10.5, so I'm guessing that's where that 10.5 came from, is represented by the equation velocity equals square root 2 times 9.8 times 10.5. Estimate the velocity of the ball. Round your answer to the nearest tenth. Well, I'm thinking that my equation is important, so I'm going to copy the equation. V equals 2 times 9.8 times 10.5. Well, I don't see anything to plug and chug. I'm just going to work out the problem and solve it. So take your calculator and do 2 times 9.8 times 10.5. When you do that on your calculator and multiply that together, you should get 205.8. But that's not the answer because I need to go back and find the square root. So type square root on your calculator, and you should get on your calculator an answer of 14.345731. Plus 10 bears, I beat you. That, by definition, is an irrational number. It's not terminating, it's not repeating, it keeps going, there's no pattern. Irrational number. Round your answer to the nearest tenth. That's my tenths place. I'm going to look at the neighbor to the tenths. If it's 1, 2, 3, 4, leave it as it was before. So when I round this to the nearest tenths place, it will round to 14.3 plus 10 bears. If this digit right here was 5, 6, 7, 8, 9, then I'd go back and add 1, and then my answer would be 14.4 if that was 5, 6, 7, 8, 9. 14.3 meters per second. Bam! One more, and then off to watch the Bulls. Hopefully when you'll know tomorrow if I'm in a good mood or not. All right, peeps, last problem. The area of a square tablecloth is 30 square feet. Estimate the length of one side of the cloth. Round your answer to the nearest tenth. All right, there's my square cloth. The area is 30 square feet. I want to know one side. Well, if I figure out one side, I know what all the sides are because it's a square. A couple different choices. You could say the area of a square is base times height. You could say the area of a square is length times width. Or plus 10 bears, because I'm really going to press you with my math knowledge. The area of a square is also known as the side squared or multiplied by itself. So in any case, I'm going to plug and chug. Pick whichever formula you want. It doesn't matter. I'll use this one. And I'm going to plug and chug and put 30 in for A. So I need two numbers. One's my base and one's my height that I can multiply together to give me 30. But these numbers have to be the same. Why they have to be the same? Because it's a square. So the easiest way to solve this problem would be to take your handy dandy calculator and do 30 square root. Drum roll, please. Brrr, and that gives you 5.47722255 plus 10 bears. Irrational number. First of all, 30 is not a perfect square. That's worth another 10, not a perfect square. And it's not terminating, and there's no pattern here for it to repeat. If I go back and look at the directions, it tells me round your answer to the nearest tenth. I'm going to look at my tenths place right here. Look at its neighbor. If this is 5, 6, 7, 8, 9, move the 4 up the number line. This is a 7, so I'm going to move the 4 up the number line. That would round up to 5.5. And I'm not going to get minus 10 feet. And I will get another plus 10 because if this number right here in the hundreds place was 1, 2, 3, 4, you would leave the number as it was before. If this was 1, 2, 3, 4, you would just leave it as 5.4. All right, guys. Hope that helps you on lesson 6.3, rational and irrational numbers. Stay tuned for our next podcast on lesson 6.4. And our podcast on lesson 6.4 will be on simplifying square roots. See ya. Wouldn't want to be ya.